Today's lesson is section 8.6, and it is the law of sines. So we only have two lessons left. One is the law of sines, one is the law of cosines. And I bring both of them up because everything we've done so far in this chapter, in chapter 8, dealing with triangles and some type of trigonometry, all of the triangles have been right triangles so far. So what if we're faced with a triangle that's not a right triangle, but I need to find either an angle measure or the length of a side? Because we also can't use Pythagorean theorem because that is only able to be used on right triangles. So the law of sines and the law of cosines are two formulas, key concepts, whatever you would like to call them, ways for us to solve for triangles that are not right triangles. So the very first thing, and actually maybe I should write that down for us. So cannot we use this on non-right triangles, okay? So we're not able to use SOHCAHTOA today because that's only able to be used on right triangles. So what the law of sines says, it says let triangle ABC be any triangle with A, B, and C representing the measures of sides opposite the angles with measures capital A, capital B, capital C respectively. So notice how capital angle A is opposite the lowercase a. So lowercase letters are representing the side lengths, capital letters are representing angle measures. And then with that being said, we can set up these three ratios. Okay, we know that the sine of A over A is equal to the sine of B over B and the sine of C over lowercase c. So to solve this triangle, we would actually only need two of these to set up our proportion and solve using cross multiplication. So our second key concept box says the law of sines can be used to solve a triangle in the following cases. So the first case is you know the measures of two angles and any side. Okay, so any two angles and any side of a triangle. Sorry. Case 2 is you know the measures of two sides and an angle opposite one of those sides. All right, so, and I've been saying this whole time that we're going to use this to solve triangles, so let's figure out what solving a triangle is. Solving a triangle is actually finding the measures of all the angles and sides of a triangle. Okay, so we know a triangle has three angles and it has three sides. So when the directions ask us to solve a triangle, we have to find 6 total pieces of information. All right, so let's move into example 1 so that we can see a little more clearly without just words, how do we use law of sines? So it says to find P. Now this is lowercase p, so that means it's a side measure. And then we have to round that to the nearest tenth. So we have P, Q, and R. So P, I know the angle, and I know the side. Angle R, I know, and I know side R. Notice how they did not give us any information about Q. They didn't give us the angle measure, and they didn't give us the side length. So we're not even going to use Q. So you pick. You can either do the sine of R or the sine of P first. I'm just going to go ahead and do P since it's on the left there. So I'm going to do the sine of P over side P is equal to the sine of angle R over the length of R. So substitute in what we know. The sine of P, well, that's 17. The length, oh, we don't know, so we'll leave that P. The sine of angle R is 29 over the length of R is 8. So now we can cross multiply. So I'm going to get 8, well, I guess I'll use my p on this side. So I get p times the sine of 29 is equal to 8 times the sine of 17. You are more than welcome to go ahead and type the sine of 29 in your calculator, type 8 times the sine of 17 in your calculator, convert those to decimals, but I prefer to wait until the very last step. So I'm going to divide both sides by the sine of 29, because remember, that's just a number. Don't let it worry you or confuse you. It's just a number. So I divided both sides by that. So we end up getting that p is equal to 8 times the sine of 17 divided by the sine of 29, which if you type that all in the calculator, you should get approximately 4.8. All right, so using the law of sines, it's actually not any more difficult than setting up a proportion and cross multiplying. So let's take a look at example B, because that one was us finding the length of a side. Now for B, they're asking us to find the measure of an angle. And they didn't give us a triangle here, so we have to draw our own triangle. That's okay. So find the measure of L to the nearest degree in triangle LMN. So I'm just going to draw a triangle, label it L, M, N. So that means this is little l, this is little m, that's little n. So it's telling us that little n is equal to 7, little l is equal to 9, and angle n is 43 degrees. All right, so to solve this problem, it's asking us, to find the measure of angle L. So I guess I need that too. So this is the one we're looking for. Well, it's good that they gave us the angle across from it, and then they gave us angle n and side n. So those are what we're going to use. So I'm going to do the sine of L over lowercase l equals the sine of n over lowercase n. So I don't know the sine of L, so I'm keeping that the sine of L. Lowercase n is being replaced with 9. I'm going to get the sine of 43 all over 7. So again, we can cross multiply here. I'm going to go ahead and just multiply both sides by 9. So I get the sine of L is equal to 9 times the sine of 43 divided by 7. Again, you are more than welcome to type that in the calculator before you continue. But we need to get L by itself. So think in your head, how do I get rid of sine? Well, we do sine inverse, but remember what we do to one side, we have to do to both. So we actually end up getting that L is equal to the sine inverse of this whole big thing. So 9 times the sine of 43 all over 7. And then if we type that in the calculator all at once, we end up getting the angle L is approximately 61.27 degrees. Okay. All right, so you guys have 2 your turns to do. So take a moment, try both of those, pause the video, come back, and then check your work. All right, so you can see that the first one, we should get C is approximately 8.5. All right, and for the second one, you'll see that we end up getting the angle T is approximately 34.47 degrees. All right, moving on to example 2. It says solve triangle DEF if angle D is 8, angle F is 112, and the length of side F is 12. Round angle measures to the nearest degree and side measures to the nearest tenth. So remember, they said to solve the triangle. So that means we have to find 6 different pieces of information. With that being said, they gave us 3 of them. They gave us 2 angles and a side. So we have 1 more angle and 2 sides to figure out. So let's go ahead and start by drawing a triangle. So we have triangle DEF. Right, so DEF. Angle D is 8 degrees. Let's read a little angle. F is 112, so you can clearly see my picture is not drawn to scale, and side F is 12. But that's okay. All right, so we have to find side lowercase d, side lowercase e, and angle E. So the very first thing we can find that's the easiest is angle E. Because it's a triangle, we know 2 of the 3 sides, so we can find the last one just by subtracting both of them from 180. So the first thing we're going to do is find the measure of angle E. We're going to take 180 minus 8 minus 112, or 180 minus 120, and we get 60 degrees. So therefore, we know that that is 60 degrees. First part finished. Now we either have to find D or E. I'm going to go ahead and find D because that's first in the alphabet. So I'm going to do the sine of 8 over D equals, now we can't use angle E because we don't know side length E. And if we accidentally made a mistake finding the measure of angle E, then we're already shooting ourselves in the foot by using that to find side D. So we're going to use some of the information they gave us. So I'm going to do the sine of 112 over 12. So cross multiply here. I'm going to get D times the sine of 112 equals 12 times the sine of 8. I'm going to divide both sides by the sine of 112. I'm just running out of room here, so I'm just going to write that D, once you take, let me actually see if I can write it here. There we go, I fit it in. Once we divide those, we get that D is approximately 1.8. All right, so there's 2 things we found. We only need 1 more because they gave us 3 pieces of information. All right, so the last thing we're going to find is side E. So I'm going to do the sine of 60, which we have to use in this case because we have to find E, is equal to, and I'm going to use 12 and 112. So the sine of 112 over 12. So E times the sine of 112 is equal to 12 times the sine of 60. And then divide both sides by the sine of 112. We get that E is approximately, I should have written my approximately, there we go, 11.2. So I'm going to try to find a place here to write all of them. So angle D, angle E, angle F. So D is 8, E is 60, F is 112. And then lowercase d is 1.8, lowercase e we found is 11.2, and lowercase f they told us was 12. So there's all 6 pieces of information. All right, so Yep, I guess we'll do example 2b. I was going to skip it just for time's sake, but we'll go ahead and do it. So now we have to solve this triangle. So I'm going to draw my triangle, except this time they're giving us a little bit different information. Last time they gave us 2 angles and a side. I bet this time they give us 1 angle and 2 sides. So H, J, K. J is 32 degrees. Side H is 30. Side J is 16. So we have to find, and I'll try to color code it this time. We have to try to find angle K. We have to try to find angle H. And then we have to find side K. All right, so doesn't matter what we find first. I'm just going to go ahead and find angle K. So let me get my orange out. So can I find angle K first? Nope, can't find angle K first. Okay, I need to find angle H first. And you're probably wondering, well, how do you know that? So I was looking here, and for me to be able to find angle K, I have to know side K, and I don't know that. So, but angle H, I do know side H. So that's why I have to find H first. I don't have a lot of room here, so bear with me. So H, so if I do the sine of H, that's going to be over 30, and that will equal, now I have to use angle J and side J. So the sine of 32 over 16. Going to go ahead, cross multiply, and divide all at once. So I get the sine of H equals 30 times the sine of 32 divided by 16. And then if I do the sine inverse, so I have to do the sine inverse of both sides. And then you're going to want to type all that there in the calculator, but I'm running out of room. We end up getting that the measure of angle H should be approximately 83.5 degrees. Okay? It says to the nearest degree, but I really hate rounding something to the nearest degree if it's a decimal. So I'm going to leave mine like that. All right, so that is H. Now we can find angle K. I almost forgot for a second what I was doing. So if we know that this is 83.5, we now have 2 of the 3 angles we need. So to find angle K, we just need to take 180 minus 83.5 minus 32, and we should end up getting 64.5. So angle K is approximately 64.5. So the last thing we need to do is to find the side length of K. So now I'm going to use the sine of 64.5 divided by K is equal to the sine of 32 divided by 16. So again, cross multiply. Try to show some of the steps here. So I'm going to get K times the sine of 32 is equal to 16 times the sine of 64.5. Divide both sides by that. All right, so once you go through, you end up solving all of that. You get that K is approximately 27.25. Yay, we fit it all in. All right, so take a moment, try the your turns. I think for the your turn, sorry, it looks like the formatting here got a little messed up. But A, you could just do all the work there if you want. B is asking you to find S, and C is asking you to find T. So take a moment, do those. I'm only going to be putting the answers down for these next two to save time because these notes are a little bit lengthy today. So go ahead, work on those, and then come back and check your work. All right, so there's A, B, and C for the first your turn. Oh, the second your turn looks much better. Angle V should be 31 degrees. Angle U should be 106 degrees, and U should be 16.9. All right, and now moving on to the fun math story problems, because who doesn't like a good story? So it says a 46-foot telephone pole tilted at an angle of 7 degrees from the vertical casts a shadow on the ground. Find the length of the shadow to the nearest foot where the angle of elevation to the sun is 33 degrees. So fortunately for us, they drew this picture. So this, what I know confuses a lot of students about this, is that 7 degrees, it is this angle way down in there. So that teeny tiny little part of angle D is 7 degrees. And we have to find the length of the shadow. So remember, shadows are always on the ground, so we have to find that part. Okay, so we know this angle and this side. So that's good. I can at least use that part, so I'm going to go ahead and put that in. I know it's going to be the sine of 33 over 46. And I know x is going to be down on the bottom, but I need the angle opposite that. Oh, so that's that angle up there. So we have to do a little bit of work before we can find that angle. We first have to find this angle here. Because if I can find that angle, then I know 2 of the 3 angles, I can find the third of a triangle. So before I put that little color in there, if you notice, there's a right angle measure there. And so that means if this little piece that arrow is pointing to is 7, that must mean the rest of this is 83 degrees. So now if I take 180 minus 83 minus 33, we end up getting that this angle up here is 64 degrees. So now I have the angle that I want to find the opposite side for. So now I do the sine of 64. All right, so again, we're going to cross multiply here. Divide both sides. We get x is 46 times the sine of 64 all over the sine of 33. So x is approximately 75.9, and this is in feet. So the shadow is approximately 76 feet. All right, so you have one last your turn to do. Again, it's not a right triangle. They gave you 2 of the 3 angles. So make sure you read the question and then come back and check this whenever you're done. All right, so hopefully you're able to figure this problem out. Looking at the picture, you needed to find how much fishing line that is cast out above the surface of the water. So that's the side of the triangle that I labeled X and highlighted to be darker. So we first had to find angle B and then set up our proportion and solve, and we get that there is approximately 42.04 feet of fishing line let out above the surface of the water.